Good morning, everybody. Today we are going to discuss about one important technology used in Ethernet. Ethernet, basically, it is a LAN protocol. General topologies used here are bus and star topologies. The technology behind this one is carrier sense multiple access with collision detection. Details we'll see in coming slides. Basically, Ethernet is developed in 1980 by three companies. One is Digital, second one is Intel, third one is Xerox. On combination, this is named as DICS. Later, in the year 1985, the Computer Society of IEEE started a project, IEEE 802.3, which discusses various possibilities to implement Ethernet, starting from the cabling, technology, and efficiency. All these things are published in IEEE 802.3. Generally, IEEE Ethernet and IEEE 802.3 almost similar in way, except minor differences. Most of the time, generally we use IEEE Ethernet and IEEE 802.3 like same technologies, but actually if we see the inside details, there is a minor difference that we'll see in coming slides. So what are the different kinds of Ethernet possibilities? If you see, one category we say classic Ethernet, second category we say switched Ethernet. Basically, classic Ethernet is the original form and varied from 3 Mbps to 10 Mbps, whereas switched Ethernet is from 100 to 1000 and 1000 to 10,000 Mbps is possible. Afterwards, even we are trying with 10 gigabit Ethernet also. But when you see nowadays, most of the LANs are switched Ethernet. If you see the Ethernet sketch here, it is the first sketch drawn by the company to install Ethernet. Basically, you have to install a cable like this with end terminators this side as well as this side end terminators, and in this cable you have to take a tap so that this will be inserted into the core element so that you can take the signals. Like this you can take many taps. It depends upon number of nodes you want to install. If you see the details of one node, after inserting into the main cable, this is connected to the interface, then it is connected to the controller, finally it is given to the system. So this is the basic sketch for Ethernet. If you see the overall idea of this one, you have to install a cable. After that you have to select the number of nodes. From each node you have to take a tap so that we are communicating through cable. So this is the basic idea of the Ethernet. Now if you see the classic Ethernet and switched Ethernet, this first diagram indicates the classic Ethernet where we have one cable, all nodes are connected to this cable. Coming to the switched Ethernet, already in last classes I have shown a switch with basically 24 port switch, and twisted pair we have seen category 6 probably in VLSI lab, I hope. So this type of environment, so we say that is switched Ethernet. Nowadays all LANs we are using with this type of technology, that is switched Ethernet technology. Now coming to the data link layer is classified into two sublayers. One is logical link control, second one is medium access control sublayer. So here our concentration is Ethernet, especially it is related to medium access control sublayer. It gives the solution for accessing of the channel so that one can communicate with others. So name itself is the indication who will access the medium. That is our basic idea in Ethernet. So now first we discuss Ethernet cabling options, then we discuss encoding possibilities. After that we are going to discuss about the protocol, and suppose if there is a collision, how we are going to resolve, what is the Ethernet performance, and various types of Ethernet. This is the flow how we are going to discuss about the Ethernet. So cabling point of view as a overall idea, if you see your standard Ethernet implementations classified into four categories. One is thick coaxial cable, second one is the thin coaxial cable, third one is the twisted pair, fourth one is the fiber optics. These are the possibilities. Here 10 base 5, if you see, basically this 10 indicates data rate, nothing but 10 Mbps. Base indicates baseband communication. This 5 indicates length of that segment, maximum segment possibility. So this 5 indicates 500 meters. So that is the meaning of 10 base 5. So 10 indicates 10 Mbps, base indicates baseband communication, 5 indicates 500 meters is the maximum segment possible. So this is the discussion of name, and first possibility is thick coaxial cable, second possibility is thin coaxial cable, third is twisted pair, fourth one is the fiber optics. So why do you need all these types of cables? Earlier in the beginning days, thick coaxial cable is installed in a particular room. From that various connections are taken with the help of thin coaxial cable. So this is the basic idea of the cabling. When you see the twisted pair, nowadays all LANs we are using this type of twisted pair. Coming to fiber optics, when you use fiber optics, suppose you want to carry the signals from one building to another building, then we will go for the fiber optics. So this is best between buildings. When you go for twisted pair, this is the cheapest system. But when you coming to the first two possibilities, thick coaxial cable and thin coaxial cable, earlier we used this type of arrangements, but nowadays we are working with twisted pairs and fiber optics. In between buildings we are using fiber optic cable. Within a room we are working with the twisted pair. So with the help of switch, we are connecting all nodes with the help of twisted pair. So this is the first possibility, thick coaxial cable. Your maximum segment size is 500 meters. So here systems are connected with the help of tappings like this. So this way so many systems are connected, even server also connected. So this is the basic idea of thick coaxial cable. When you come to the thin coaxial cable, your maximum segment size, when you see here 185 meters, this is the thin coaxial cable. So this is the thin coaxial cable, maximum segment size is 185 meters. Here also we take taps to the system so that we can communicate through this cable. So if you see this arrangement, it looks like this. Earlier we used all LANs, this type of arrangement we insert. This is the basic communication between cable and system. But nowadays we are using LANs with alpha switches. Already we have discussed about network interface card. So this is the part in our computer. So with the help of RJ45 we are connecting to the switch. Like this, all NIC card, nothing but node, nothing but a computer. So your computer through NIC card we are connecting to the switch with the help of category 6 cable with RJ45. So when you see the typical scenario, suppose you consider three departments: ECE, CSE and EEE. So within this, suppose you consider four nodes, all these four nodes are connected to the switch. Like that, CSA also we have four nodes, all are connected to the switch. In EEE also we have four nodes, all are connected to the switch. Like this, all these things, three individual labs once again connected to the another switch. So this is the backbone which carries one building to another building. So there onwards you can work out with the fiber optic cable. So basically fiber optic cable, if you see, you can install fiber optic cable. Here we are showing actually hub to computer, but nowadays these fiber optic cables are implemented one building to another building. These are the references. Our main reference, Tannenbaum, that is the Computer Networks 5th edition, and you can refer even data communication and networking, that is the Ferozian, and you can also see the TCP by IP protocol suite, that is also by Ferozian, and some diagrams are taken from the internet. Thank you for your attention.